All right, here we go. So, oh, sorry, any questions on this example? Okay. Well, for subtracting, I mean, subtracting is a little more tedious, but not much more. I mean, you don't get to pick the order though, because subtracting is not commutative. And you also have to remember to distribute the minus sign. You know, you have to make sure you do that. And if you were to subtract vertically, when you distribute the minus sign, you end up turning it into addition. You'll see when I do an example of that. You'll see what I mean. But let's subtract horizontally. Again, what you want to do is you want to distribute this minus sign. I don't know if you can see the cursor on the screen or not, but you distribute it. You know, that's just how you subtract. Just how it's done. I hope I can do this without making a mess. Okay, and then of course, you know, and then once you do that, right, you have minus 7x to the 4. That's here, right? Minus 4x cubed. That gives you minus 4x cubed. Minus 2x squared. Minus is plus, right? Signs alike is positive. Signs unlike negative. Minus again is plus. Minus plus is a minus. And now we're back in addition, essentially. I mean, once you distribute that minus, you're basically back in addition. You know, that's what happens. Okay, so now we're going to look for like terms. So let me change the color on the pen here. Okay, so we have 12x cubed. What can we combine that with? Well, not this term, not 1, no. Here, this term. Right, and when we do that, we get 12x cubed minus 4x cubed. Okay, that's good. What about minus 3x squared? Can we combine this with anything? Well, let's see. 1 minus 7x to the 4 minus 4x cubed, 2x squared. Right? The minus 3x squared and 2x squared are like terms. So we put them together. Plus 1. What else? These terms are, let's see, not minus 7x to the 4. Right? We can't do that. These terms are taken. X, we can't combine it with x. Minus 1 we can. So we have 1 minus 1. And the minus 7x to the 4 and x, those are terms that are left over. Okay. Combining, we get 8x cubed minus x squared. Okay. Right? That's minus 3, excuse me, let me say it again. 12x cubed minus 4x cubed. That's 8x cubed minus 3x squared plus 2x squared. That's minus x squared. 1 minus 1 is 0. Minus 7x to the 4 stays here. X stays here. And really, in a sense, you're done. You just want to take the 0 away and write this in standard form, which I do here. So basically here we have minus 7x to the 4, right? The term with the highest exponent of x goes first. Then we have 8x cubed. That's going to be next. Again, you want the exponents decreasing as you go from left to right. Minus x squared, then plus x. The 0, again, we can just disregard. So that's one example. Any questions on this? Okay. So now I want to show how to subtract vertically. And again, unfortunately, you really can't choose which one is on top. That is because subtracting is not commutative. Okay, so but when I say subtract this polynomial from this one, right? This is really what we're calculating. We're subtracting this, the second, from the first, taking the second from the first. So again, this is what we're calculating. So I have these columns made up already, right? This is the one on top. Each term gets its own column, right? There's no x term, so I use 0 here to hold the x place, so to say. I mean, you really don't, I mean, you could write this as 0 times x if you want. Wait, let me change that color. Make it red. There we go. Want to be consistent with the colors I use? So you could use 0 for the 0 times x you can use if you want, but we just have 0. And now what we do is we want to write this polynomial below it. Now, watch this. You probably, hopefully can see what happened, right? There's a 7x to the 4 here, right? As you can see, the leading term here was 12x cubed. So we had to make an extra column to the left to handle the 7x to the 4, as you can see. There was an extra column made to the left. And again, I put a 0 up here just as a placeholder. You could leave it as 0 or do 0x to the 4, whatever's easier for you. Really doesn't matter that much. Then, like terms go in the same column. So 4x cubed goes in this column. Here, let me get the laser thing, like so. Minus 2x squared goes in this column, minus 3x squared, as you can see. This is the x column. That's what this x could remind you of. Minus x goes here, 1 goes here. So we had to make an extra column, but that's okay. Easy to do. Now, I'm going to take this minus sign. I'm going to distribute it. And then what's going to happen is it's going to convert to addition. Excuse me, this is going to change into addition. That's a better word. So in other words, as you can see here, right, the minus sign, I'm going to distribute it, and then addition is going to be left over. I mean, really, that's what we did when we subtracted horizontally. We distributed the minus sign, but then we added. We followed the same procedure for adding. So this becomes plus, right? This was 7x to the 4, now it's minus. This was 4x cubed, now minus 2x squared. Oh, sorry, this was minus 2x squared, now it's 2x squared, and so on. Once we do that, now we can combine, and that's what we do. We have minus 7x to the 4, right? It changed into addition. 12x cubed minus 4x cubed, right? That's 8x cubed, as you can see. Minus 3x squared plus 2x squared, that's minus x squared. 0 plus x is x. 1 minus 1 is 0. And we get this answer. Again, the 0 at the end, you don't have to write it down. I mean, if without thinking you did on a test or something, I'm not going to mark it wrong. So I'm not going to be that cruel. All right. Any questions on this? Well, it was so much fun. Let's do some more examples. Let's do another one, actually. Okay, so we're going to add these two together. Okay? All right. So again, since we're adding, it really doesn't matter which one goes on top. So I'm going to use this polynomial since it has more terms. X to the 6 is its own column. There's no x to the 5th term, so I'm using 0 here as a placeholder, as you can see. So I mean, I could just leave it as 0. Let me be consistent with what I was doing today. You could also leave it as 0. You could also write 0 x to the 5th. I mean, I'm not honestly sure. I don't think it's really mathematically precise to write 0 x to the 5th, I think people would just write 0. But if you wrote 0x to the 5th or 0x or whatever with me in this method, that's fine. I won't take off points. Then we have x to the 4, x cubed. So you can see each term gets its own column. Okay, 2x, 5. Now we have to handle this polynomial. If I do that, let me take care of the recording.